All right, I think we're going to start. So, today we're going to have a relatively short lecture, but anyway, as important as it is, as other lectures, and we're going to talk about Node.js Package Manager, or NPM for short. And NPM is a package manager. Every language has one. NPM is the one for JavaScript. It came with an introduction, or should I say, like extraction of JavaScript from the browsers. An introduction of Node.js by Ryan Dahl at some point. You'll be learning about Node.js in more detail in the later course. But now we need to get one of the things that Node.js introduced, and this is a package manager. So, as I already said, package managers are a common thing in programming languages. Python has its own package manager called pip. Java, I believe, has its own package manager, and C# with its nuggets. So you can think of the package manager as the way to share and reuse some of the stuff that we code, so that we exercise the whole thing about not writing, not creating new stuff that's already been created by some other people, probably more experienced than we are folks, because they've been maybe longer in the industry. Maybe they have higher standards in the company that created that package. So it could be other way. So this NPM, you can think of it as an online storage system that will contain more than, like now I think it's like several million of packages. And these packages will contain like 90%, almost like I think 99% of modern web apps, meaning that it is a very important thing to have, and it's a very important thing to have correctly set up in the project. So people would just download some of the code that is already written before them, then create some new stuff specific for their business. And we have a newly created solution for business clients, whether it's like front end or back end or maybe some infrastructure, that stands on top of the shoulders of giants from the NPM registry. So when people say registry, they mean some kind of an online storage that acts in a similar or like almost identical way as the official NPM registry. That will contain their packages that they would like to share with other projects and automate their installation. So this is how it looks. So if you go to npmjs.com, you'll see that it's basically a huge Google search for different libraries and solutions. Some small, some are big, like React, for example. Like all of the frameworks that you've heard, they're basically available in the NPM registry as a single package. You can just download it using your local NPM CLI tool and use it right away. So kind of a nice way to summarize all the ideas that people had about reusability and centralized storage system for the language. So with an introduction of NPM, JavaScript finally set on path of becoming a mature language, as well as like general type of language, general purpose language, as other languages like Python, C#, maybe C at some point. So the way you do stuff with NPM is that whenever you have your node installed, you will have an automatic ability to use NPM just by typing NPM in your console, and then word install to install some package, and the package name. And NPM will automatically connect to the specified registry. By default, it will be like online registry that like most common people use, like global registry, I should say. I will download the package, install it correctly with all the dependencies of that package. So by downloading some high-level stuff or framework like jQuery, you download all the packages that the jQuery package use. So it's kind of a way to work with NPM. And we'll also work with our special PACKAGE.JSON notation that we'll learn a bit further down our lecture. So once this command is executed, you'll have a package log created that will contain all the dependencies specified for this library. And you'll have your library created under the current directory that you're currently in, so npm install example, and then node modules. It might look really tiny, as in the example of jQuery installed, but in some projects it will be really long list of dependencies that a project has. So to keep track of all the dependencies that project has, we will be creating or automatically create using npm CLI tool a package.json file that will basically describe what this package has. So to summarize, package.json file is a special type of file that documents the whole package dependency tree, not the dependency tree, but the dependencies that are like specific for this package. And the package log itself that we saw on the previous slide is the one that actually documents the dependency tree, which kind of goes down to the very first library or libraries that contain no dependencies. So by looking at the package.json file of any package, or find on npm, or maybe on any project that you join, you'll have a rough idea of what this package, what this project is using in terms of the npm packages. You'll have your name specified, the name of the project specified, maybe the author's name specified too. And the whole idea of having the package.json is to just introduce like self-documenting, build reproducible way of developing software developing projects. So two important things that you will see in a typical package.json structure will be a name field, like the one that we didn't see that here, but anyway, we'll see a name field that will be maybe title, maybe name, that will specify how the package is named so that you can actually find it in the npm registry or install using the npm install and the name of the package. But also a very important, I think the most important thing that will like the package can have, whether in your project or in the npm itself, is a version. And we're not going to go deep into the how the versions work, how the dependency tree work. Just know that the version is a specific number that is used throughout the, like, I don't know, IT history, the industry itself, that denotes the particular version of the software that goes with this package in a form of like dot separated number that will specify the major version, minor, and a patch. So whenever a package changes, for example, I fix a small typo in some kind of a string, that will be a patch, probably. A minor version would be something a bit more substantial, could be like bug that does not break anything, but kind of makes your life easier without like breaking your project. And the major version is typically a version that does everything differently. So, and this way of specifying the package version is called a SEM version or semantic versioning. So by looking at the version of the package, it should be clear which version is the major one, which is the minor, which is the patch. So get used to that because it's used not only in the NPM, but in other version system also. So good to know. Yeah, and to summarize the whole thing I said, the initial version is usually 1.0.0. Then you have a bug fixes and minor changes, the patch releases, last number, etc., etc. That will be an increment in terms of the last digit, the patch digit. New features, maybe major bug fixes will increment the middle number, so that people actually decide which version they want to have in their code. So, for example, I don't want to have any breaking changes. I want to work with the same package, with the same API, with the same features that were in the first version, but I want to have all the patches and all the new features that they introduce without breaking anything existing. I would go for the changes in the minor and the patch, and that there is a way to specify those changes using a special syntax also, so that you have all the versions under that syntax available to you. So versioning is a huge thing. It does make sense to go a bit deep into how versioning works, but that's out of the scope of today's lecture. So how do we work with NPM? What if you want to not just install the package that somebody else has created, but actually make a package yourself? Well, NPM comes with a really nice thing called init, which will init the package or the folder that you can let in as a package. And by initting the package, you're essentially creating your own package.json that will be shipped to any clients or maybe people who consume the package, who use that package as a dependency. And this package.json, again, from a different perspective, from your own perspective, specifies what the package does in the description, where is the main file, meaning that what is the actual file that does the job, and its own like import and export statements. What is the version? How will it be available in the NPM? By what name? Some scripts that are kind of available to execute within the package. Keywords might be like tags in a typical social media network, and the author yourself. That license is usually out of scope if you're not creating any like specific open source license agreements, or maybe you work under NDA that does not allow you to share anything from the package or the outside world out of your organization. So license is usually the ISC, the open source license for the open source community in the GitHub, or MIT, also a very popular one to see here. All these fields, they're not like required to have. I mean, apart from version and name in terms of your own packages, but a nice way to give some additional information to the system, to anyone who kind of use your package. So, quick thing to remember: npm init is a CLI command that will initialize the whole flow by asking questions regarding the name, the version you would like to start with, the description you would like to provide, and in the end of this interrogation list, I should say, you'll end up creating this package.json automatically. So yeah, a nice reminder what every field does. The author field, which is the one that is important and sometimes not just for creating new packages or using new packages, but also when you work with not the global registry of packages, like the one that is available for anyone, but also for your organization registry, where the sensitive files are kept, the sensitive packages are kept, private packages. you need to know that with the NPM, you have an ability to set your local machine email and name, maybe a license by default. So same as with the Git configs, you have an NPM configs, and you either set it like manually typing every field value, like a key value pair, or you have an ability to use the npm config and just open the .npm rc to see all the configs that you specified. So bear in mind that all the npm or maybe CLI specific package managers, in general, CLI configurational stuff is usually under your own like home directory users and your name, and they'll usually start with .npm and the name of the configurational file. So .git config or something, .babelrc, .eslint.rc, and for the npm it's the same kind of thing. So .npm.rc will contain all the configs specific for your installation, the npm. So that package.json thing is not immutable once created. It is supposed to be mutated once while the project grows and changes its dependency tree. So you can either edit manually, changing any of the fields. It's just a JSON file. So for example, if I wanted to have a next version of the Lodash library, I will just bump up the manual version of, if it's available, if I know it's available, bump up the version by writing it 2 instead of 1 here, and then doing the npm install. It will download that version, install it. So it's kind of like a way of keeping track of, as I said already, keeping track of your dependencies. So you have a full control of what's installed and where it's installed, what environment it's installed in. So you will have different types of dependencies depending on the environment. But anyway, you can also do that from the CLI. As we saw with the jQuery example, you specify the npm install command, and then you can either specify the name of the package right away, or you can specify which dependency would actually be saved into. So it has the default values. By default, as I remember, prior to some version, it was not saving your file. So in the old npm versions, you would have to actually type the -save to have it available in the package.json. Now it's not necessary. And by default, it was saving everything under the dependency object space. And to save it under the dev dependency, the development dependencies like linting or maybe testing, anything containing not the actual production bundle of your dependencies, but everything that you're going to be using during development, but not on production, you'll be saving under the dev dependencies. So to do that, you'll just specify --save--dev and same name of the library. There are shortcuts. I will be showing that to you in a moment, but just know that it has some default behavior where it saves your dependencies under the dev dependencies, under dependencies just for production, or the development and production, or the peer dependencies. There are a number of ways to save your files. So as you can see, if I specify the --save--dev image min and the second version, I'll be installing the image min under the dev dependencies and starting with the second version. So this is how it looks like. And the and the socket.io goes into the dependencies because it didn't specify the -dev dependency save dev. That's why it went into the dependencies. You can there is a specific topic about managing your dependencies. it seems they're concerned about like bumping up versions. And you do that mainly because the versions in NPM are constantly changing as people who maintain those dependencies, those packages, they don't just stop at the moment where you downloaded the package. They continue contributing to the package, adding new features, fixing bugs. So if you wanted to keep up to date with their fixes, and it is a good way to keep up to date, you need to manage your dependencies, and that's where you have different tools of how NPM could be helping you to manage your dependency tree. And for example, one of the commands that is available to use npm list that will list the same thing as in the package.json, but kind of like nested into each other, showing the dependency tree and how it looks under the hood. You can also have the outdated specified, so that npm go through your file and compares it to the most recent version from the online registry, compares it to your local one, and says whether it makes sense to update it or not. It also has different types of commands for the auditing. So when you actually do the job of managing your dependencies and you want to find if you whether you have severe security risks, security bugs in your dependency trees, whether there is a, I don't know, the Patreon support available for any of the favorite libraries that you might have. You can do that also using the npm CLI. And whether you would like to update something, you can either specify it like directly, npm update, and name the package with the version, or just run npm update, and the npm just goes and updates to the latest and greatest version. You have an opportunity to specify the depth of that update, meaning that whether the npm has control over the specifying the majority of the dependency version it's going to update, or they want to just update the minor and patch versions. So you have control over that, and that's usually set up in the npm-rc config file. So yeah, that's how you manage dependencies. A very important topic in the package.json file is a scripts topic. In every package, you can specify how you work with the package by specifying the short and like executable commands that could be done within your package. It's not just the code that you are shipping. It could be the code that you're working in that could be tested, linted, built, maybe run into a specific mode, like a dev mode, like we see here. So scripts section is a way for NPM to wire up into the NPM CLI, a way of building or running some of the commands that are available inside your application. So as you can see, I specified the 3 commands. These are key value pairs, where the key is the one you're going to be using within the CLI itself by running npm run and then the name of the script you have. And the value is a bash script that will be executed. It's either the npm script, some kind of the shorthand that you want to save as a macros, reusable alias kind of thing, or maybe a completely different program that's going to be repeatedly used by those who be using your library, and you want to provide a shortcut for that too. So as you can see, it has some library chokedo that's going to be accessing everything related to JavaScript and under RCC directory, and the command that is going to be running under those files, for those files, will be npm run build.js. and npm build.js will be running Babel instead. So you kind of have a cross-reference between the scripts doing the npm run in the value itself. So you can just either specify it manually, npm run watch.js with this part, and then npm run build to run this part, or you can even shortcut the whole thing to reduce the manual work by just appending some of the commands to the values itself. So you kind of have a way to deal with the whole automation thing. And when people say about the automation, the CI/CD, and all of that, and the Node.js and the JavaScript community, it's mainly about having some scripts that have some specified commands that should be run in a sequence. So for example, typical CI/CD example, the automation example would be, hey, download the package, it is already done, and then npm run test to test it. Once you're done, npm run build, and once you're done, put everything that you created under this folder into the deployment environment. So npm scripts is a way for JavaScript community to automate some of the stuff in the packages that they develop. So whether you're gonna be developing packages to be saved on the npm registry, or whether it's gonna be just a project that you're gonna be keeping in the GitHub as a project, you most likely be using scripts section of the package.json under your project, and probably your DevOps team will be using the same package.json to have packages installed and scripts run in their automation, continuous integration, continuous deployment pipeline. So kind of important and ties the whole thing together. In the package.json, you also have some ability to specify events, kind of events, because sometimes you want to have an ability to react to certain things within your package, within the process some of the scripts run. So a very well-known notation will be the prefix or post prefix that specifies what command should be run before the test, what should be run after the test, maybe what should be done before I commit, or what should be done before I push the changes. So you can imagine that using the package.json, you can actually force developers to work under certain conditions so that they need to run tests or need to lint their own code, their own changes before they even able to push anything to remote. So NPM also has that ability to specify that. There are a bunch of libraries to do that. Husky is the most well-known to force developers to run lint and to run tests before they push the changes. But you can also do that with any other commands. It's completely up to you. And that is the end of the presentation, but might not be the end of the lecture. So if I were to show you some of the stuff that I talked about, so let me just close the lecture and open the terminal. So to wrap up the whole thing, I'll show you how to create your project from scratch and how the project should be created, not like manually, but using the CLI. So you're gonna be getting used to using the CLI. So in the folder that contains one of the previous lectures that we have about asynchronous stuff. I want to create a new folder there. So maybe not the folder first. Yeah, let's create a folder, touch, test folder. Maybe there's an NPM lecture folder. yeah, so we'll move there. NPM lecture. Okay, yeah, well, so oh, it doesn't allow me to do that. Okay, let me just test. Touch test. Come on, don't embarrass me with that. Okay, there's something weird with my directory. Maybe I'd not allowed in the section. Never mind. It's not really about the Unix commands anyway. So I have an ability to run npm, and if I just do that, or typically you'll do something like, I think that, yeah, to make sure that you have npm installed. So I have the 6.9 version of the npm. It's not the latest and greatest, but anyway, it works. And if I run npm init, okay, really work creating package.json. It kind of covers the most common. Okay. Oh yeah, it wants me to specify the name of the package, and I want to have a test. Maybe npm testing. Version will be default one. Description will be npm testing lecture file, just a bunch of words. Entry point will be index.js. Test command will be, yeah, default one. Git repository also give default keyword. I want to have npm. Author will be me, and the license, let it be MIT. That's what it creates. It has a summary of creating that. Okay, yes. Do I have it created already? Let's see. So if I open the whole thing in VS Code, yes, I do trust the authors. This is the package JSON it created. Oh, I see. Let's see what I did there. Let me just quickly delete it. Okay, so package.json was created, and I don't have any dependencies installed yet, but I do have a way to test it. What if I add the start that should, I don't know, echo hello. Do that. This is how I add commands. And since I'm in the same directory already, I can actually try to run npm run test, as we learned from the lecture. It tries to run it, but it doesn't have anything specified, so it fails, obviously. And if I go to run on start, it just tries to run it as a command, and yeah, same thing happens. So if I were to install a new package, I could just run npm install, and for example, I want React. Let's see what it does. It did something because it did not fail. So if I'm missing something, or if I'm doing something wrong, you know that the Linux will fail. But I installed something. I added 4 packages from 3 contributors. And I have now a package.json created, and this is what it created for me. So it installed React. It also installed some additional libraries that probably are used on the React itself. It says that it requires those libraries, so lose and intensify. This is the one. Object assign is also a library that it requires. Object assign didn't have any required, so it was not install additional libraries, but the lose and envify actually require JSON tokens, so that's what we installed, and that's it. JSON tokens did not require anything, so and we end up with 4 libraries basically installed into our own repository. And the Node modules now looks like this. So everything that we see here in the top level, so loosely Object.json and React, is the same as we see here. And the bin folder is the folder that could be used as a way to launch something. Some libraries are the old-fashioned libraries. They don't use the latest and greatest NPM run and etc. and then can be launched. They can be pushed and delivered with scripts available to run them properly as the author actually intended. So I have an ability to work with React now. So, and if I were to create an index.js and then maybe some Webpack, you might know what it is, and then I went and actually required React and see I already have an ability to do that, and then I can go and maybe start a component. So nothing too fancy. You don't need to know React to do that, but still, I know that the React actually ships with the component itself, and I can see that it has some of the code written already that I did not write, but anyway, it's available from the React library, and I can see that. And also explore every library that I installed and their package.json file to see what they rely upon. So as you can see, this is what it came with. So it required, from the way that my package.log.json looks, it required some of the libraries, and I can confirm that it required those libraries by going into their package.json and seeing that they have the dependency, the production one, requiring the same library. So it kind of like ties the whole thing together. We also have some fields that, as you might tell, might be something related with private fields. That's something that NPM has internally, so you don't need to specify it in when you write your own package.json. It will be automatically appended to the package.json file of libraries that you install. You also have maybe how you launch it? No, nothing about that. So you can actually go and explore the library itself. It could be written in a way that you actually able to read the whole thing. It could be minified or like gzipped for production. So as you can see, it's like an old var use code, so for the backward compatibility, and also it's a development one, so it's going to be using a development version of React. The production will be really stripped to almost nothing most of the time. Yeah, and also minified to the degree that it's not readable. So, but you actually can read and go through the library and change it locally if you would like to, but that's like kind of outside of the scope of today's lecture. So yeah, that's how you work with React. So now I just need to do something with my project to make use of those libraries that I installed. And that's it. Yeah, that's how the whole thing works. Maybe you have some questions for the NPM. Okay, cool. Maybe I did a good job of telling you what NPM is and how you can use it. Maybe you already know that, but keep in mind that it's a common thing for any computer science related stuff or language, I should say, to have some kind of package management, to have some registry of like packages that other people write, and where you can download those packages. It will be probably a CLI tool, so nothing really specific to JavaScript, but good to know if you're coming from no background in programming. Okay, so thanks for your attention. And yeah, see you guys next time. Thanks.